Well, welcome back, and let's learn some more about linear regression. So we have in 3.2b linear regression models, and the first thing is what we have is a least squares regression line. And so when you're talking about least squares regression line, pretty much what you want to know how to do is how to create this on your graphing calculator. Most probably have a TI-84. If you have an Inspire, I'm sorry if you have a Casio, I have no idea. But in order to figure this out, what we're going to do is we're going to take our TI-84, go to Stat, go to Edit, find our List 1, List 2, Stat, calculate linear regression, and we have this. Another thing that you probably want to know how to identify and maneuver is using a box, okay? A box of statistics right here is for 2 bivariate data. The first thing that you want to identify is the constant. Now, when they talk about this constant and we have coefficient, this is known as the y-intercept, okay? That is a y-intercept. This right here, okay, this is talking about what is coming out. This is the slope, okay? That is the slope. All right, and we have some error analysis coefficients, which we will talk about later in further chapters. But for right now, this is also known as the standard deviation of the residuals. All right, standard deviation of residuals. We're going to talk about that later on. This is your R squared value, okay, and that's an adjusted R squared value. And just so you know, how do you find the R value? All right, your correlation coefficient, you take the square root of R squared, okay? And that's how we do that. Now, all of these are really important. So if you were to label this, you want to say, okay, y hat equals negative 14.7, all right? And that's going to be plus 0.001x, okay? We want to label this y hat because it's our predictor. All right, that's what we're predicting. This is our slope, and then whatever our x value will be plugging in to change. Now, when we talk about residuals, if you recall, this is our standard deviation of our residuals. And so that essentially, if you recall what residuals equal the actual minus the predicted value. Okay, and so when you talk about the standard deviation residuals, this essentially is what on average is the residual amount that is from the actual amount, okay? And so now the next thing is, how do you determine if you have a linear model? This tells you how to create a linear least squares regression line. Next thing is it actually a linear model? Now, we do not look at the R value, and what we do is we look at a residual plot, all right, residual plot. I'm looking for is a linear model is appropriate when there is no pattern in the residual plot, when there is no pattern in the residual plot. When there is a pattern, all right, then it is not linear. And I'll give you an example, okay? Right here, what we know about residual plots is if we have a bunch of different dots and they're all kind of random explanatory residuals, positive, negative, and all different ones, this is good. This tells us that we have a line. A bad residual plot is where we have our positive and negative residuals, and it forms a pattern, usually a curved pattern or an up and down pattern. And if there is a pattern, that would tell us it is not a line. It is not a line. This is actually probably more like a parabola, okay, when we're doing that. Other things that you can see right here is that when you have your residual plot and you see if this is following a line, you can see that you're going to have a bunch of values going up and down. Okay, so this might be a good set of data. All right, that could be represented by a line. Like I said before, when you have a line, this still could have a relatively high to moderately high correlation coefficient. But as you plot the residuals, you see, okay, this is not a linear pattern. And you probably can see this in the data as well, but this will identify it. One final thing is when you're using a least squares regression line, the line with the smallest sum of the residuals squared, that is what we're getting when we get that least squares regression line, if you want to put that down for your notes. All right, so this is information about how to create a least squares regression line using your calculator, using it from a table of values, all right, or the value table. And when we're writing that out, how to identify using residual plots, we're going to go through some examples in just a little bit on using these notes.